Today we are going to learn preparation of salts. So today's lesson we are going to divide into two parts. In the first half, I'm going to introduce the general idea of making salts, and then in the second half, I'm going to introduce a method to prepare the first type of salt, the soluble salt. Before I go through the notes with you, I want to use an example to help you to understand what factors we need to consider when we are making any kinds of salt. 好，咁今日我想用一個好簡單嘅 example 去同大家講解下我哋preparation of salt 嗰時要 consider 要考慮啲咩 factor。好，咁其實 preparation of salt 就好似我哋煮餸一樣，因為其實而家停咗課，咁啲學生都係留喺屋企啦。有時爹哋媽咪晏晝翻唔到屋企，咁啲學生都係要自己煮飯食㗎。OK， 譬如我有個學生今日想整切雞飯自己食。OK， 咁第一步佢一定會諗我要買啲咩嘢先可以整到切雞呢？咁佢就可以上網 search 下啦，上網會話俾你知要買啲咩嘢。OK， 呢度拎晒所有要買嗰啲材料。OK， 咁第一步就係要find out 我哋需要啲咩材料先可以整到呢味餸。好，第二步我哋就要諗，我哋係咪買咗咁多嘢返去，我哋就擺晒啲嘢落去一口鍋入面煮熟佢就係切雞就可以食得呢？ OK， 咁 turns out 一定唔係嘅。咁我哋繼續睇一睇有咩 step 我哋要 follow。佢第一步講咗啦，咁我哋首先要拎走啲內臟，之後我哋要洗乾淨啲雞肉先可以煮。咁呢度就好似我哋 preparation of salt 一樣，其實喺成個過程入面係有好多side product 產生嘅。你要考慮埋幾時係會有啲 side product 啦，同埋我哋用咩方法將啲 side product 同我哋最尾想要嗰個 final product 可以分開。Okay, now I change back to English. So just like the example I have given to you.Okay, so when we consider what we are going to do to make a salt, we need to consider two parts. The first part, what do we need? And the second part is that, is there any side product formed in the process, and how can we separate those side product from the product that we want? Okay, so the first parts. Unlike the example I have shown to you, that we can find all the raw materials we need to cook the dishes we want. Okay, for this unit, you need to consider what are the raw material you need to make the salt. Okay, and there is a simple way to consider it. Remember, in the last lesson, we have learned the definition for salts. So they are formed when the ionizable hydrogen ions of the acid are replaced by metal ions or an ammonium ion. Okay, so for a salt, it should consist of two parts, a cation and an anion. Okay, so if we want to make the target salt contains A as a cation and B as the anion, then we should provide the cation A and also the anion B. For example, if we want to make copper 2 sulfate, then we should have something that can provide copper 2 ion. Then it would react with something that provides a sulfate ion. Okay, and then it would form the target salt that we want, which is copper sulfate. But please remember, cations and anions cannot exist on their own. What does it mean? So you would not be able to find a solution that only contains copper 2 ions in it. And you would not be able to get the raw material by just buying a copper 2 ion solution. It's similar like you cannot buy just only the left foot shoe without buying the right foot shoe. They always be paired up with the oppositely charged ion. Okay, just like our shoes, it always comes in a pair, left foot shoe with the right foot shoe. Okay, so in this way, then we need to consider what are the two reactants we need to use to provide the cation A that we want. Okay, and then this one, there is a mistake on your notes. It should be the anion-D that we want. Okay, and after the reaction, it should form the our target salt, which is AD, and then it will left with a side product BC. Okay, so of course we need to remove the side product, but here I also want to mention that unless we put in just a right amount of the two reactants, otherwise we will have some of the reactants that's in excess, and we also need to remove them in order to get the pure target salt AD. Okay, so that's the first part we need to consider. So how to choose the two reactants. If we only consider the two reactants, that one of them contains the cation that we want and the other one contains the anion that we want, there are loads of combinations. But among those combinations, which one is suitable to be chosen to make the salt? What is the criteria that we need to consider when choosing the two reactants? So here, remember the example I have mentioned to you. Okay, there are some side products formed during the reaction, and we need to consider, can we avoid producing a lot of side products, and is there a way that we can remove those side products or separate our product from those side products? Okay, so let's consider some examples together. So here we have an objective that is to make copper 2 sulfate. Okay, so we need something that can provide copper 2 ion, and we also need something that provides a sulfate ion. So here, the first choice is copper 2 oxide react with calcium sulfate. Okay, so both of them are in solid state. Would this reaction be a good choice to make copper 2 sulfate? Okay, so later we're going to discuss in detail. So if both of them are in solid state, actually they won't have any reaction. Okay, because there won't be any reaction between solid and the normal condition. Okay, and then we move on to the second choice. For part B, we have copper 2 nitrate, and then we also have sulfuric acid. Okay, so now copper 2 nitrate, because it's nitrate ion, nitrate salt, so it must be soluble, so that's a solution. And sulfuric acid, in order to perform the acidic property, is also a solution. Okay, so for these two, would any reactions take place? The answer is yes, but there is a condition for that. It's only when hot and concentrated sulfuric acid that's being used. Okay, so after undergoing the reaction, the resulting mixture should contain, of course, it should contain our target salt. And then, what will be the side product? So if the target salt take away the cation and the anion that we want, then it should left with the things that didn't include in the target salt. Okay, so which is the nitric acid. And maybe we will have some unreacted reactants, which are copper 2 nitrate or sulfuric acid. Okay, that's the second combination. And then take a look, the third combination. So for this one, we have copper 2 oxide and together with the sulfuric acid. So copper 2 oxide is in solid state, sulfuric acid is in aqueous state. So any reaction between these two, so this reaction we have learned before, they would have a chemical reaction. And after undergoing the reaction, the resulting mixture should contain, again, the side product would contain water, and the unreacted reactant would be sulfuric acid and copper 2 oxide. Okay, so now let's consider, can we separate those unreacted reactant or the side product from the resulting mixture? For part B, take a look. Originally, we have two solutions, okay? And now we have unreacted reactants. They are also solution, and our side products is again a solution. So how can we separate our target salt, which is a solution, from the rest of the solution in the mixture? Okay, very challenging, right? And there should be no easy way to separate it. But for part C, let's consider the same question. Okay, at the beginning, we have a solid react with the solution. And now, our side product is just water, so it will become the solvent. And water is actually quite easy to remove, right? Water has a pretty low boiling point, I would say. Okay, and then let's consider how can we remove those unreacted reactants. First, how to remove sulfuric acid. Okay, an easy way is just to add more copper 2 oxide. Okay, so as we keep adding copper 2 oxide, it will react with those excess sulfuric acid in the mixture, isn't it? And then if we adding too much copper 2 oxide, and then copper 2 oxide become the one that's in excess, then how can we remove the copper 2 oxide from the mixture? Okay, so here you need to notice that copper 2 oxide is in solid state. So would you be able to remove a solid from a solution? Okay, I believe you have done similar experiment like this. Okay, in order to remove a solid from the solution, you just need to do filtration. Okay, so using a funnel and a filter paper, you could easily remove those solid unreacted copper 2 oxide from the mixture. Okay, so the method is called filtration. Okay, so to summarize, you need to know. Okay, so to prepare a soluble salt, for example, copper 2 sulfate, first you need to contain two reactants, which should be one that contains copper 2 ion, the other one contains sulfate ion. And then the solid reactant should be in excess. Okay, in order to remove all the solution, unreacted solution in the mixture. Okay, and also then we can easily remove the solid reactant by filtration. So by using the previous example of making copper 2 sulfate, let's summarize a general rule of preparing the soluble salts. So here, I wanted to highlight this part. Those soluble salts we are talking about in this section should exclude the sodium and potassium and ammonium salts. Okay, so for these three, we're going to discuss in part C in detail. So using the rules that we have mentioned just now, we should have a reactant that contains the the metal cation here, okay? And then we should have another reactant that contains the anion that we want. Okay, so a good choice for the anion would be an acid that contains the anion we want. Okay, so usually we could use hydrochloric acid, sulfuric acid, and nitric acid. Okay. Remember, on the previous page, we have discussed in order to easily remove the unreacted reactants, we should have a solid react with an aqueous solution. Okay, and we need to make sure that the solid is in excess. And then we could easily filter out the solid to maintain the designed target salt. Okay, so now let's consider what are the solids that we can use that contains the metal cation and also can react with the acid. So now recall your memory. What are the possible reactions you have learned that between metal or metal compounds that can react with acid to produce aqueous solution plus water? So there are three possible ways. So the first one, if it's a pretty reactive metal, then you can just put in the metal itself. For example, if you are making magnesium sulfate, then you can just put in magnesium metal. Okay. And then the second choice, you could add metal oxide or metal hydroxide. Remember, we have excluded the sodium and potassium ammonium salts. So the rest of the salts which contains metal ions, they should be insoluble, so as a solid. So here, if you add metal oxide or metal hydroxide, it would just undergo a neutralization reaction with acid. Okay, and this method can be used if the metal cation is not very reactive and cannot directly react with acid. For example, copper. If you're just dropping a copper, if you just dropping some copper metals into the acid, for example, sulfuric acid, you will see no reactions under room condition, right? Okay, so in that case, we can add copper 2 oxide or copper 2 hydroxide to make the solution happen. And the third choice, we can also have metal carbonate. Okay, so again, for those carbonate, because it excludes sodium, potassium, and ammonium salts, so they are all insoluble, hence in solid state. Okay, so remember that above solid must be in excess. Okay, and the reason for that is to ensure that the acid has been reacted completely, and then the excess solid can be separated by filtration. Okay? Now, let's try another example. If we have magnesium sulfate as the target salt, then what are we going to choose? So first, we need to choose an acid that contains sulfate ion. So of course, we're going to choose sulfuric acid. And then we need to choose a metal or metal compound that contains magnesium. So since magnesium is a quite reactive metal, so we can simply drop the magnesium metal into the acid, and then we can get the magnesium sulfate as the product. Okay, and then there is the side product is a gas, so it just escapes and we will not be bothered with it. And for the second choice, we can have magnesium oxide or magnesium hydroxide that react with sulfuric acid. So here the side product will be water, Okay, so it's just become the solvent, and later we would learn how to remove those water solvent. And then we will have magnesium carbonate that can react with sulfuric acid. So if we use magnesium carbonate, then we will have one more side product. But the carbon dioxide produced is in gas state, so it just go away immediately when it formed. So again, we don't need to bother with it. Okay, and then again left with water, which is a solvent, then we can easily remove the solvent. So here you can go online to watch the video that how we do the magnesium sulfate salt. Okay, so it involves several steps, and when we have time, when we after the school has resumed, I will let you to try to do an experiment to make the crystal on your own. Okay, but it should involve a step. Okay, so first we should add the excess solid reactant into the acid, and we need to stir it and make sure they fully react with each other. And then we need to remove the solid excess solid reactant, and then it will left with the water, which is a solvent, and also our target salt. Okay, so now since water is water got a pretty low boiling point, so it's quite easy to remove water. So how do we do it? So first we heat the filtrate to concentrate it. Okay, so we try to evaporate the excess water in this filtrate. Okay, so filtrate is the things that we left with after filtration. So down the bottom, the solution we have here is called the filtrate. So we evaporate the excess water and got a concentrated filtrate here. And then we cool the hot concentrated filtrate at room temperature to obtain some small crystals. And then we would filter the crystals formed from the remaining solution. Okay, and then we wash the crystal with a small amount of cold DI water, distilled water. This process is to assure that we wash away all these waters on the surface or other impurities on the surface of the crystal. And then we dry the crystal by using filter paper or an oven or desiccator. Okay, so here I have attached a video that shows you how we grow copper sulfate crystals. And if you have paid attention in our chem lab, actually we have a large sample of the copper 2 sulfate crystals, okay, which have been left for years. Okay, so again, if we have time, I will let you to try to grow your copper 2 sulfate solution when we go back to school. Here I want to add one more thing. Okay, so after we heat the filtrate, we're not just concentrating the solution, but also there is one thing that you need to know is that when we increase the temperature, usually the solubility of the substance increased. Okay, so that means at a higher temperature we can actually dissolve more of the target salt in the solution. However, remember in the next step we cool the hot concentrated solution to room temperature. So as the temperature decreased, those target salt that can originally dissolve in the solution now cannot dissolve in the solution anymore. So now it will form some crystals, and those crystals are pure substance. And this way can also be used to purify a soluble substance, which we're going to discuss later. Now let's move on to the checkpoint question for the first section. Please pause the video here, attempt all the questions, and listen for explanation. So question 1. Which of the following substances are appropriate for preparing zinc sulfate by mixing with dilute sulfuric acid? Okay, so our targeting salt here is zinc sulfate. So we need to have an acid that contains sulfate ion, which is the sulfuric acid, and then we should have something that provides a zinc ion. So it can be zinc metal, okay, because zinc is pretty reactive, so it can directly react with acid. So we can put a tick for the first one. And then we can also have metal oxide. The metal should be zinc, okay, so the second choice also works. And the third choice, zinc carbonate, yes, that also works. So the correct answer should be D. Question 2. Which of the following pairs of substances would react when mixed? First one, copper and ethanoic acid. Remember the reactivity series that we have learned. Copper is not very reactive and it would not be able to react with acid at room temperature. Okay, so we can put a cross for the first one. And then copper 2 oxide and dilute hydrochloric acid. Metal ion can react with acid readily, so we can put a tick for the second one. And third, we have copper 2 carbonate and dilute sulfuric acid. Again, metal carbonate can react with acid readily, so we can put a tick for that as well. So the correct answer should be C. Next one. Question 3. Which of the following statements about crystallization is correct? So crystallization refers to the process that we have mentioned on the previous page. So this part. Okay, so by heating the filtrate and then let it cool to form the crystal, this process, we call it crystallization. Okay, so take a look at the following options. A well-formed crystal can be formed from hot concentrated salt solution by fast cooling. Okay, so for this process, we want to let it cool slowly. If we cool too quickly, or if we just put it into the ice bath, then it will cool down too quickly, and not just the target salt that gonna form the crystal, but it gonna also combine with other impurities to form the crystal. So it would not be able to form the pure crystals from this process. So let's put a cross for that one. B. A newly formed crystal should be washed with hot water after filtration. Okay, so for this part, remember we have mentioned we should only wash it with small amount of cold distilled water, because the hot water would dissolve our crystal. Okay, so there is no point of doing the whole process. So let's put a cross for that. And C. Solute particles need time to arrange themselves in a regular pattern to form large crystal. Yes, so that's what's happening in crystallization. That's why we get a clear and a good-looking pure substance out from crystallization. And last one, crystallization cannot be done under room temperature. Yeah, that's quite obvious. We need to leave it to cool down at room temperature, okay, so it can form the small crystal that we want. Okay, so put a cross for that. The last one, copper 2 sulfate can be prepared from copper 2 oxide and sulfuric acid. Explain which of these reactions should be in excess. Okay, so in this question, copper 2 sulfate, which is a soluble salt, is a target salt, And then we have the two reactants, copper 2 oxide, which is a solid, and sulfuric acid, which is a solution. Okay, so first of all, you need to be clear that we cannot have both of the reactants in excess. Otherwise, they're gonna have reactions again until one of them becomes a limiting reagent. Okay, so which one should be in excess and which one should be left in the solution that can be easily removed? Okay, so if we have sulfuric acid that's in excess, okay, that means there's no copper 2 oxide left in the mixture, and then the mixture will contain sulfuric acid and also copper 2 sulfate. Okay, so both of them are soluble. So how can we remove sulfuric acid from the mixture? But if we have copper 2 oxide that's in excess, okay, that can make sure there is no sulfuric acid left in the mixture. And also copper 2 oxide, since it's an solid, it can be easily removed from the mixture solution. Okay, so the answer should be copper 2 oxide. Okay, since in excess it can consume all the acid and prevent it from contaminating the target salt. Okay, and also since it's solid, it can be easily removed by filtration. Okay. Part B. To wash the soluble salt produced, why a small amount of cold distilled water is used? Okay, so in order to prevent the crystal redissolve in the water, okay, we need to use a cold DI water, not the hot water. Okay. To prevent the crystal Okay, last question. What will be the observation when the copper 2 sulfate crystal obtained is dry to anhydrous? Okay, so if you still remember the copper 2 sulfate crystal that we have in our lab, that's the giant crystal sample in our lab. It's in blue color. Okay, so that's because it contains water in the salt to form a complex ion. However, if we dry it, okay, to anhydrous, means there's no water present in the sample, then the color would change to white. So it would no more be blue crystal, it's gonna turn into white. Okay, so again, for more information, you can refer to the two videos attached here. So before I end this lesson, I will leave a question with you to consider. And please write your answer on a piece of paper and then post it onto Google Classroom, and also to our WhatsApp group, okay? And then we can have some discussion about it. So what is a question? So in this session, we have learned to make soluble salt. And then the next part we're going to consider is how to make insoluble salt. So here I will give you an sample. How can we make magnesium carbonate? So try to come up with as many as you can of the reactions between two reactants that can produce magnesium carbonate. Okay, just write as many as you can, and then try to circle one or two methods that you think will work the best among all the reactions that you can think about. Okay.